Hello, welcome to the fourth lecture of the software engineering course at the UL. In this lecture, I'm going to start with the second chapter of this course after we finish the first chapter during the previous lecture, which was lecture 3. This second chapter, we will start talking specifically about software design. We will tackle the first topics related to software design. First, we will talk about how to start with the process of designing software by visualizing any institution that we want to design a software for, by visualizing this institution as a complete system. Once the software engineer visualizes the institution as a system, he or she can know more information that will help him there to design the required software correctly and completely. So the objectives of this chapter will be as follows. First, you should understand at the end of this chapter that organizations and the members of the organizations are actually complete systems. And the analyst should, in order to understand the needs of the organization, the needs of the software that he is going to develop, and to understand how the objectives should be satisfied, the software engineer should visualize the organizations and its members as a complete system that works in order to achieve certain objectives. Once the software engineer understands how to depict the organization as a complete system, then he or she can depict a certain graphical view of the complete system of the organization using a certain type of software or the model, such as data flow model, entity relationship model, use case model, which we are going to talk about in this lecture, in this chapter. Sorry. Using this type of software, we can draw a certain model that will show us the complete organization as a comprehensive system that works all together in order to achieve certain specific objectives. In addition to that, we are going to talk about the factors that affect the design, such as the management levels, the organizational culture, and so on. Okay, so these are what I'm going to talk about in this chapter in general. So we will have four major topics in this chapter. The first one is how to describe and depict organizations as systems, which will be the main topic in this lecture. Then we will talk about how to depict these systems graphically, how we can draw graphical representations that will depict the whole organization as a single system. Mainly, we will be talking about data flow diagrams, entity relationship models, and use case modeling. We will talk briefly about each one of these and how it can help us to understand or to achieve a comprehensive overview of the complete organization as a system. Then we will talk about factors affecting the description of the system. When we depict the organization as a system, we will talk about what are the factors that will affect this description of the organization as a system. We will focus on two factors, which are the management levels inside the organization and the organizational structure, organizational culture. Let's start with how to visualize organizations as systems. So when the software engineer wants to design a certain software for a certain organization, it's very important that the software engineer or the system analyst understands well the complete organization, its operations, its departments, how data flows inside the organization, what are the general and main processes that the organization operates and uses. All this will help the software engineer understand how does the whole organization operate and how does it work in general in order to achieve its main objectives. In general, any system or any organization will have one or two main objectives. These objectives can be explained and divided into sub-objectives and several targets and missions of the organization. But whenever you want to summarize the whole organization, you can summarize it in one or two objectives. In order for the software engineer to understand well the organization, he or she should start from the main objectives that summarize the whole organization, and then he or she should see how these objectives are actually divided between the organization departments and within the organizational structure of the organization. So we can say that any organization can be conceptualized as a system, a complete system that has predetermined goals and objectives, predetermined set of specific goals and objectives. As I said, each organization will try to achieve specific goals and objectives. These can be summarized in something called the mission statement of the organization. Each organization should have a mission statement. The mission statement will contain these one or two main objectives of the organization. In order for the organization to achieve and fulfill its mission statement, it should describe or it should specify how different departments and sections in the organization work together to achieve the objectives of the organization. So the one or two main objectives, they are divided into sub-objectives and targets and goals. And then these targets and goals, they are divided between the departments and sections of the organization. So we can say in general that any organization can be composed or can be divided into subsystems. These subsystems, they might contain one or more departments and sections within the organization, and each one of these subsystems will work to achieve a certain objective or set of objectives among the comprehensive objectives of the organization. So the software engineer or the system analyst should be able to understand well how the organization is divided, what is the main mission statement of the organization, how this mission statement is divided into a specific set of targets among the different departments and sections of the organizations, and how does these departments and sections work together to each one of them achieve its own objectives, and how does each one of them collaborate with the other departments and sections, and how do they work together in order to reach the total and comprehensive mission statement of the whole organization. This is a very important requirement that the software engineer should work on in order to be able to design a successful software for the organization. A specific point, very important point, is that whenever you understand how the organization is divided into subsystems and departments, you should always remember that the various subsystems of the organization, they are always interrelated and interdependent to each other. So there will never be a certain subsystem or department that is isolated from the other subsystems completely. Each subsystem should have relationships and dependencies on other subsystems. You will never find any department within the organizations that work in isolation from other departments. In general, any system that exists, it processes inputs from its environment. It takes inputs, then it processes these inputs to it performs certain operations and functions on these inputs, and then it produces certain outputs, which are the outputs of the system. Any system can be depicted by inputs, processes or operations, and outputs. Now, any system should have certain boundaries that separate the system from its environment. We will see in the next slides example of system and its boundaries. Very important for the system in order for it to continue to work correctly. It's very important that the system maintains a stream of feedback from its environment. So whenever a system works and operates to achieve certain objectives, the system should always get feedback from its environment in order for it to know the possible methods for it to improve and enhance. Any system that doesn't enhance will definitely fall backwards and eventually it will fail. An ideal system always self-corrects or self-regulates itself, which means that all the numbers within the system should always work on the feedback that the system collects from its environment in order to know how to use this feedback to improve and enhance the system. If the system doesn't make use of the feedback in order to improve itself, in order to enhance itself, then the system will not be able to continue at a certain point in time. So the ideal system is the system that will be able to make use of the feedback that it collects from its environment in order to know how the system should be improved. This is an example of a university system. As you can see within the big oval, we have several subsystems. These subsystems together, they constitute the university system. So we have the administrative subsystem, we have the staff subsystem, and we have the faculty, or we have the academic subsystem. The academic subsystem will contain faculty, teaching, research, students. The administrative subsystem will contain the administrative staff, the tutors, the administration, various administration departments. And we have the ordinary staff, such as the IT, the library, the learning resources, the external relationships, and so on. All of these will constitute the system of a university. Now, what is the environment that this university system deals with? It deals with a vast environment, huge environment. For example, it deals with the government for policies and regulations. It deals with schools and colleges to get students from them and let them know its programs and its requirements. It deals with many other parts of the community and the society. So all these, they form part of the environment of the university system. Now, what is the boundary of the university system? It is the relationships and the interactions that it makes with its environment. So each part of the environment will have a certain relationship, and there will be certain interactions between the system and its environment. These interactions, they will form the boundary that isolates or that makes a limit between the system and its environment. So as I said before, each system each system in general will take certain inputs from its environment. It will process them, and it will execute certain operations within the system on the inputs in order to produce certain outputs or achieve certain targets that are the objectives of the system. Very important is to acquire this feedback loop. So you need to always acquire feedback that will show you how much good is the performance of the system. This feedback will be used to compare it with the targets or the goals of the system. So the targets or the goals will specify what is the expected performance of the system. You take the actual performance when you produce the outputs, you take the actual performance of the system from these outputs, and then you compare the actual performance with the target performance, with the goals that you set as part of the mission of the system. You compare these. If the output performance meets or exceeds the target performance, then the system is operating very well. Whenever you discover any lag in the performance of the system, which means that there are parts of the operations of the system that need improvement. So you should take into consideration that there is a lag in the performance of a certain aspect of the system. You need to discover from where did this lag come from, and work on certain parts of the system to improve them in order to make all the outputs of the system perform or meet the required performance of the target of the system. This is called the feedback loop. So when the system is able to automatically compare the target inputs or the target outcomes with the actual outcomes and deduce from the comparison what objectives or targets are lagging, and then know from this comparison what parts of the system should be improved or enhanced in order to enhance the performance of the system, then we call this system a self-regulating or self-correcting system, which is in this case an ideal system. So this was a general overview about systems and how to depict them. Keep in mind that whenever you want to design software for a certain company, you need to perform this analysis and to understand the organization in general as a complete system, understand what are the target outputs of the system, what does it want to achieve, and understand its inputs and how to operate and process the inputs in order to produce the outputs of the organization for the system. So let's talk about details related to the system visualization. First, there are two types of systems based on openness and closeness. We have an open system and we have a closed system. What we mean here by open and closed is it is related to the data of the system or the information produced by the system. An open system, you have a free flow of information. You don't have any restriction on any kind of information related to the system. All the data or information related to the system is free. Anyone can know about this data or this information. So in general here, the subsystems of the system will be related to each other freely, and the output from one subsystem becomes input to another subsystem within the system, within the complete system, without restrictions on the inputs and the outputs. So there are no inputs or outputs that are secret to a certain subsystem. On the other hand, when the system is closed, then there is restricted access to information inside the system. Not all information is free to be known by all members and subsystems in the system. In this case, certain subsystems will have secret information and rules that identify which members of the system or the subsystems are able to know certain information. So in this case, in the case of closed system, then the information will be according to a need to know basis. So whenever you need to know certain information according to your job, then you are given the capability of accessing this information and retrieving it. When certain information you don't need to know about it, then this information is kept secret from you and it is known only to those who need to know it. This is called a closed system. For example, a bank is a closed system because in a bank, not all employees in the bank are able to know about all the information that is stored inside the bank. This is an example of a closed system. Most systems, most business systems, they are actually closed systems. Another important concept related to systems is about the functional and non-functional requirements of the system. Now, these are very important because once you want to design a new software, you need to identify at the beginning what are the functional and non-functional requirements of the software before you start your design. After you collect the information about the software from the employees and the clients or the users of the software, you need to identify these functional and non-functional requirements. What's the difference between these two terms? The functional requirements, they identify a certain behavior or functionality or service within the system. For example, when we say this system should authorize users to access the system, this is a functional requirement. This system should create an account for each new user. This is a functional requirement. So any service or operation that should exist within the system, this defines a certain functional requirement of the system. On the other hand, a non-functional requirement represents a certain constraint or condition that should exist in the system. For example, when we say that the system should operate 24 hours per day, 7 days per week, this is a non-functional requirement. When we say that the system should be able to handle 1,000 users at the same time, they should all be able to log in together to the system. This is a non-functional requirement because it is a certain constraint or condition that the system should satisfy. So in general, we can say that a functional requirement specifies a certain service or operation, describes how the system should behave when it executes a certain service or functionality. On the other hand, a non-functional requirement explains a performance characteristic or a certain condition of the system. The best is to see them via examples. So we are going to take examples related to functional and non-functional requirements. First, with respect to functional requirements, let's look at these examples. For example, the system should be able to process certain data. This is a functional requirement. The system should be able to authenticate users. Each user that will want to access the system should be authenticated by the system, which means that the user should enter authentication data such as username and password, and the system should check that this data is correct. So this is a service or function that exists in the system. This is a functional requirement. The system should create a new account for each user. This is also a functional requirement. The user should be able to withdraw money from his or her account. This is a functional requirement. The system should compare the incomes and the expenses. This is also a functionality, a service that exists within the system. This is a functional requirement. For example, the manager information in the database should require clearance. So if the manager wants to enter into certain information related to the manager, then he or she should make a clearance to the system in order to be able to access this information. This is also a service offered by the system. All of these are examples of functional requirements within a certain system. On the other hand, non-functional requirements specify a certain quality or property that should exist within the system. For example, if we say that at least 100 users should be able to log in to be using the system at the same time, the system should be able to handle 100 users concurrently. This is a non-functional requirement. Another example, which I specified before, the system should work 24/7. This is also another non-functional requirement. The database should be able to store at least 100,000 employees' accounts. The size of the database should be such that at least 100,000 accounts should be created within the database. This is a non-functional requirement on the size of the database. The system should recover from an error within a maximum of 1 hour. This is also another condition which specifies a non-functional requirement. In general, non-functional requirements, they are very difficult to achieve. Functional requirements, they can be achieved and you can make sure that they are integrated and they are fulfilled within the code. You can make sure that a certain code fulfills a certain functional requirement. On the other hand, non-functional requirements, they are very hard to fulfill. It is very hard to make sure that the system could handle 100 users. The only way that you can achieve this non-functional requirement is that you test it. You test the system, you make 100 users log in at the same time, and you test the system and see if it actually is able to continue working normally 100 users are logged at the same time to the system. This is the only way to make sure that this non-functional requirement is actually fulfilled and achieved by the system. So in general, we can say that non-functional requirements, they are very hard to assess and make sure of them than functional requirements. Another concept that we want to talk about before talking about the organization as a system is the concept of virtual organizations. This concept is really very important, and its importance has increased in the last years, especially during this time, this specific period, due to the situation the world is going in. You can see that if you search, you can see that many organizations, they are now turning into virtual organizations, and many employees within organizations are becoming virtual employees who work from home instead of working physically at the organization location. So a virtual organization, it can be identified, it can be described as an organization that doesn't have a specific physical location at which the employees of the organization gather and work. On the other hand, a virtual organization, it doesn't have a specific physical location. It is a virtual location on the internet, virtual organization on the internet. So the employees of the organization, they perform their work and their duties to the organization online. They might work from their home, from any other location as they want, and then they finish their work and submit it and perform it on the internet. In many cases, the virtual organization contains teams of workers. The teams will divide their work together among them. Each member of the virtual team will perform a certain part of the virtual work, and then they will combine their work together and submit it to the organization. In this case, the organization doesn't have to have a headquarters or office. It can simply be organized by combining people from various places and assigning work to them, assigning work to each one of them according to his jobs and requirements. There are many benefits of virtual organizations for the organization and also for the members of the organization. One of the benefits is for the organization, for the owner of the organization, is that the owner doesn't have to buy physical facilities. So you don't need to buy an office or rent an office. You don't need to buy any physical facilities for the offices of the employees. You just need to assign the employees online and monitor their work online, and then assess the value and their performance after they finish their work. Also, another benefit for the owners of the company is that when the organization is virtual, the customers will get the feedback and will get response to their inquiries more often and more rapidly. Which means that when in case of virtual organizations, in most cases, the teams, the members of the virtual organization, they are required to respond fast as possible to any inquiry or query from a client. In usual cases, in physical organizations, employees, they have a specific work schedule, and they respond to queries, they respond to anything related to their work during the work times only, during the work schedule only. Whenever the work schedule finishes, then the employee is of the organization and will not involve any operation or any activity related to the organization. However, in virtual organizations, most of the time, the employees of the organization, they are required to respond to the managers, to the customers at any time, which will mean that the employees will work, their work will be divided into periods, and these periods will be separated. They will not work on a specific schedule. This might be harder for some employees, but on the other time, it might enable them to perform certain other duties that they need to perform. For example, some employees, they need to take care of their parents or their children. They need to meet their specific requirements within their homes. So working within virtual organizations will enable them to fulfill and meet these requirements. even though their work will not be organized, they might need to work at different times and within different shifts and periods. This was in general a quick overview about virtual organizations. Now let's go back to the concept of system perspective of an organization. As I said before, it's very important for the software engineer to understand the business operations and how does the business operate, what are the various business functionalities and services that are conducted and made within any organization before designing the software for the organization. It's also very important for the software engineer to understand that all subsystems within any organizations, all departments, they are interrelated and interdependent on each other in a certain way or another. When the software engineer needs to design a software for a certain organization, then he or she should review the organizational structure of the organization before tackling the design process. When the software engineer reviews the organizational structure, he is able to know about the different departments in the organization and how they are connected to each other, which department shares information with other departments, which departments depend on the work of other departments, and so on. All this information can be depicted and shown in the organizational structure. So this is a homework for you, for your general knowledge. Go to Google, okay, and search about organizational structure. Okay, you will see that this is a very famous topic. You will find many articles on Wikipedia and other business websites that will allow you to know more information about organizational structure. This is very important for the software engineer to understand, because the organizational structure, it gives an overview about the various departments in the organization and how they are related and dependent and how they work together, and which department depends on other departments, which department is below or above other departments, and so on. Okay, it also defines the roles of people within departments. Who is the manager of who works under the supervision of who, and so on. Okay, so you can see here an example of organizational structure for an organization. It shows the various jobs as circles around each other. You will find that there are many types of organizational structures. They are described here, and nowadays there are tons of organizational structures, each one having a different depiction and view than the other one. There are some structures that are vertical. So in this case, you will have a manager, then another manager below him, then another manager below him, and so on. This is called a vertical organizational structure. There are some structures that are flat structures. You have only a single manager, and then you have all the other employees below this manager. This is called a flat structure. So there is no levels of management within the organization. And between these two, we have many types of organizational structure. So the software engineer should understand the main concept of the organizational structure of the organization, and should know the subsystems and departments within the organization and how they are related and interdependent on each other. In most cases, the software engineer will face problems related to that each manager might think that his department is the most important in the organization and many other departments depend on it. And usually this happens with almost every and each manager. Each manager always thinks that his department is the most important. So it is the job of the software engineer to actually know the importance rank of each department, which department is really actually the most important among all of them, and which one is below it, and so on. You will find that in most cases the software engineer will never give a certain specific department most important than all other departments in all aspects. So the software engineer will identify that a certain department is the most important in a certain specific aspect. while in another aspect, another department is more important. So the software engineer will look at the objectives and targets of the organization, and then will know for each target or objective which of the departments of the organization is most important for this objective, for achieving this objective, okay, and so on. So we can see here, for example, that if we have an organization which contains within it 5 departments: marketing, production, distribution, finance, and purchasing. So if you look at two of among these departments, the production and the marketing departments, in actual case, you will find that these two departments will depend on each other. So the production will depend on the marketing, and the marketing will depend on the production. First, the production is the department that produces the goods or the tools that the company or organization will sell. Now these goods are taken by the marketing department and they are sold on the market, and they are advertised and in a product way, and then they are distributed and sold. So the feedback that the marketing department obtains from the actual market is used by the production department to enhance its products, its production process. So both departments, they depend on each other. The marketing department depends on the production to obtain the actual goods that will be sold, and the production will depend on the marketing department to obtain feedback from the customers who buy the product or the goods, and work on this, based on this feedback, to improve the products. If you produce any item, any product, and you don't improve it, you keep it the same all the time, then it will not last for a long time before it fails. That's why both of these departments depend on each other. The production depends on the marketing in order for the product to continue, and the marketing depend on the production in order to have products. With respect to the production manager, his department is the most important department in the company, because it produces the goods or the products, and without this production process, then there is no company. On the other hand, with respect to the marketing manager, his department is the most important department in the company, because if there is no one to sell the products, then the company will not be able to do anything, and the company will not work. So from a certain point of view, each one of these two companies is the most important to achieve a certain objective. But which one of them is the most important? You cannot say that that one of them is more important than the other. The company needs both of them. So this is the way that a software engineer should visualize and review any company. That a certain department is most important to achieve a certain objective, and all departments, they are very important and most important altogether to achieve the general mission and the general objectives of the organization as a whole. This is what we mean by visualizing an organization as a system of subsystems. Each subsystem might contain one or more departments, and knowing specifically how these departments or subsystems are related to each other, and how they are interdependent on each other. So with that, we cover the first topic of this chapter, which is related to how to depict an organization as a system. Next time I will talk about the second part of chapter 2, which is how to visualize this depiction as in a graphical way. So how to transform our depiction of the organization as a system into a graphical description. This will be the topic of the next lecture. We will be tackling 3 main types of design tools that enable us to draw the complete organization as a system. These tools are the use case modeling, the data flow diagrams, and the entity relationship model in order to design the database of the company. So until next time, thank you.